The movie industry is one of the most uncertain investment environments out there. Studios pour millions into production with no guarantee of audience reception or financial return. Our project uses historical data from the movie database to cut through some of that uncertainty and identifies patterns that actually drive movie performance. The both of us came up with two research questions. Dan's focused on genre and revenue, specifically which genres generate the highest revenue and how that's shifted over time. And my question was, is there a relationship between a movie's budget and its revenue? Together, that helped us build the 10 visualizations that you'll see today. We got the data set from Kaggle, and that includes attributes like title, genre, release date, runtime, etc. And this required a lot of cleaning the data set before we could use it. So we removed rows with missing release dates or runtimes, dropped any films reporting zero budget, and pretty much other factors that could mess with the results. For my part of this project, I was responsible for 6 of the 10 static visualizations. Each one was built using the TMDB movie dataset, and each one was designed to answer a specific question about genre patterns, how audiences rate the films, the relationship between budget and popularity, and how revenues vary across the industry. I'll walk you through each chart and the code behind it and what it actually tells us. The first visualization is a horizontal bar chart showing the number of movies in the dataset for each primary genre. To build it, I used Seaborn's count plot function, and I set the y-axis to primary genre, and I ordered the bars from most to least frequent using value counts. So the most common genres appeared at the top, and the Viridis color palette gives it a clean, colorblind, friendly look that we use consistently across all of our charts. So what you see when you look at this chart is that the dataset is heavily weighted towards certain genres. Drama, comedy, appear far more often than horror and animation. That imbalance is actually important context for interpreting every other visualization because genres with more movies will naturally dominate statistical patterns. The second visualization is a histogram of audience rating. The vote average column, which represents each film, score out of 10. I used Seaborn Sysplot with 10 bins and added a KDE curve on top. And the KDE, which is a kernel density estimate, is a smooth line that sits over the bars. What this reveals is that the ratings are not uniformly spread, and the distribution peaks around 6 to 7 out of the 10, which tells us that the most movies in the dataset are rated moderately. Not terrible, but not exceptional. The curve has a light skew, meaning there are more films pulling ratings downwards than there are upwards. Next, we have the scatter plot, comparing each movie's production budget against its popularity score. Each point on the chart is one movie, and the pattern here is interesting. Most movies cluster in the lower left corner, modest budgets with modest popularity, but as budget increases, there's a wider spread. Some high budget films achieve enormous popularity scores, but others don't. That scatter tells us budget alone doesn't guarantee popularity, and that there are genuine outliers in both directions. Low budget films that become hugely popular and expensive productions that are barely registered. The fourth visualization is a box plot comparing revenue distributions across the top 6 most common genres. What the box plot shows us is that genres differ significantly in both their typical revenue and how variable that revenue is. Action movies, for example, have a high median but are also very long whiskers and extreme outliers, meaning that the blockbuster potential is real but is also a big major risk for companies. And drama films cluster much tighter with a lower median, indicating more consistent but smaller returns. The fifth visualization is a faceted scatter plot, essentially 6 scatter plots arranged in a grid, one for each of the top 6 genres. What this chart makes valuable is the comparison it enables. For action and adventure films, there's a clear upward trend. More budget generally correlates with more revenue. But for drama and comedy, the relationship is much looser. High revenue drama films are often not particularly high budget, and that's a meaningful genre level difference that would be invisible if we only looked at the genres combined. The sixth and final visualization is the correlation heat map. This one zooms out from individual relationship and looks at how 5 key metrics relate to each other all at once: popularity, vote average, vote count, runtime, and budget. Correlation values range from -1 to +1. Looking at the heat map, the strongest relationship visible is between popularity and vote count. Films that are more popular also tend to accumulate more votes, which makes intuitive sense. Budget shows a moderate positive correlation with both popularity and vote count, reinforcing what we saw in the scatter plot earlier. Vote average, interestingly, shows very weak correlations with everything else. suggesting that critical and audience ratings are largely independent of the film's financial profile.
Now that we have seen the core problem and the initial distributions, I'll walk you through some of the advanced visualizations and the interactive dashboard we built. But before we can build these tools, we have to make sure that the data was reliable. During the preparation phase, I noticed major issues. Over 1,000 movies in the data set were reported with a budget or revenue of exactly zero. If we kept those in, it would completely skew our financial analysis. I wrote a script to filter out these zeros, drop the missing rows, and then basically just parse the messy genre data into a clean, usable format. I also extracted the specific release year feature from the date column so that we can accurately track time series. And here is our charts. Once the data was clean, we dug into the relationships between the budget and revenue. Here in the annotated scatter plot we created, as you can see, there's a clear positive correlation where higher budgets generally yield higher returns. However, we annotated at the absolute peak of this chart, which is the movie Avatar. It proves that while big budget helps, massive outliers also exist to completely break out the standard mold. Avatar had a decent budget, but also was an outlier as it outperformed many other movies with the budget that it had, and even the budget that goes beyond it. We also wanted to look beyond just money and understand the audience reception. I built this custom violin plot to show the density of audience ratings across top genres. This was a huge insight for us. You can see drama movies bulge near the top of the rating scale, meaning that they are consistently well received. On the other hand, action and horror much have wider, stretched out shapes, showing that the audience scores are highly unpredictable. But that brings us to our interactive dashboard. To bring this data to life, I developed a web application using Streamlit and Plotly. This dashboard allows users to dynamically explore the drives of a movie's success. Over here on the left, we built interactive filters. You can use specific genres that you want to filter out. Here's also the release year range. Yeah, you can see here's all the top grossing mystery movies, top grossing action movies. When I filter out the data, you can see our Plotly charts update in real time. On the left, we have an interactive scatter plot for financial performance, budget compared to revenue as shown earlier. If I hover over any of these bubbles, you can see the title and names and the exact ratings. It just overall represents the movie overall popularity. On the right, we have a dynamic bar chart that automatically calculates and ranks the top 10 highest grossing movies with our selected parameters, the color gradients to give immediate visual cues on how the audience really feels about these blockbuster movies. So over here, the lighter it is, the more popular, and then it goes down and becomes more and more unpopular. We talk about animation. Frozen peaks here, and the outlier is also an outlier as we shown earlier, so budget compared to revenue. But yeah, this is a handy little dashboard that we created to analyze between the budget and just overall the highest grossing animation movies of all time, or just overall highest grossing genres of all time. To conclude our project, we want to make sure that this was an actionable project and it can give actionable advice. If a film studio asked us how to proceed based on this data, our recommendation depends on the primary goal. If the primary studio wants to maximize absolute financial return and go for $1 billion hit, they should invest in action adventure movies. Those genres completely dominate the revenue ceilings. However, if the studio is looking for a safer, more consistent critical success with a highly predictable audience ratings, prioritizing drama films is the smartest analytical choice. Thank you for watching our presentation and exploring the TMDB dataset with us.